A common theory is that there is only a maximum amount of protein which can be utilized for muscle growth with each meal, and once we exceed this threshold of protein in a meal, the rest is essentially wasted. This implies that trainees should aim to consume smaller and more frequent protein feedings throughout the course of the day, as opposed to larger and less frequent protein feedings, if your goal is to maximize muscle growth. However, is this actually true, or is it just the total amount of protein consumed per day which influences muscle growth? In this video, we will try to answer these questions. First, we need to look at where these claims come from. Well, I think this idea first came from observing high-level bodybuilders, many of which consistently consumed a high frequency of protein feedings per day. Although this may have simply just been a strategy to consume enough total daily calories per day or to consume enough total daily protein per day, and this theory was used to justify it. Furthermore, there is some indirect evidence to support this theory. For example, this study explored the effects of consuming different amounts of protein after a resistance training session. On 5 separate occasions, 6 untrained men performed 4 sets of leg press, leg extensions, and leg curls for 8 to 10 reps, taking each set to failure. After each session, subjects consumed an egg-based protein drink containing either 0, 5, 10, 20, or 40 grams of protein. It was found that consuming higher doses of protein successfully increased the concentration of essential amino acids in the blood. Consuming 40 grams of protein resulted in the highest peak and the longest lasting increase in blood amino acids. However, this didn't directly translate to muscle protein synthesis. As we can see, the average muscle fractional synthetic rate over 4 hours seemed to plateau with higher protein ingestion. Consuming 40 grams of protein did result in the greatest MPS response, but it was only marginally greater than ingesting 20 grams. So if we were to extrapolate this evidence, it would suggest that consuming more than around 20 grams of protein per meal is essentially wasted. This extra protein would be used for energy expenditure as opposed to muscle building purposes. Furthermore, there is also evidence that we need to at least hit a minimum amount of protein per meal in order to maximally stimulate muscle protein synthesis. In particular, sufficient protein quality and quantity is required to meet the leucine trigger threshold. This is the idea that a certain amount of leucine, which is one of the essential amino acids that make up protein, is required to acutely maximize muscle protein synthesis. This was seen in this study, which compared the effects of post-exercise leucine ingestion on muscle protein synthesis. 22 healthy older women performed lower body resistance training over 6 days, combined with consuming either a whey protein drink or milk added with leucine 2 times per day. The whey protein drink contained a greater amount of total protein, around 25 grams, compared with the leucine drink, around 10 grams. However, the whey protein contained around 3 grams of leucine, while the milk-based drink contained around 4 grams of leucine, despite the differences in total protein. It was found that post-exercise fractional synthetic rate throughout the day was similar between groups. However, it was slightly superior post-exercise and at rest after consuming the leucine drink, shown in the orange, compared with the whey protein, shown in the blue. So it does seem that consuming a high amount of the amino acid leucine is particularly effective for stimulating muscle protein synthesis. And if we extrapolate this evidence, it would suggest that we want to consume enough leucine per meal to maximally stimulate muscle protein synthesis throughout the day. And in turn, this would result in superior long-term muscle growth over time. While this evidence does have some merit, we also need to take a step back and consider how relevant this really is. Because the reality is that these isolated findings aren't direct measures of muscle growth, which is what we actually care about. There are a few potential issues with making the extrapolations we mentioned earlier. These isolated findings don't consider other real-world training and nutrition variables. Most of these studies are conducted in a fasted state, so what happens if the subjects have already eaten before exercise? What happens if we eat a meal with other nutrients as opposed to protein in isolation? Even if MPS is greater following exercise in the next few hours, what happens throughout the rest of the day? And most importantly, is acute MPS data even predictive of actual muscle growth? Well, this research review explored the relationship between acute muscle protein synthesis and long-term muscle growth. Overall, the authors concluded that post-exercise MPS is more predictive of actual muscle growth outcomes in trained lifters who undergo regular resistance training, although MPS is less predictive of long-term muscle growth in lifters who are new to resistance training or when beginning a novel exercise routine. Furthermore, differences in acute MPS are not predictive of the magnitude of muscle growth difference between conditions. So overall, MPS can be a decent indicator of muscle growth in some cases, but it ultimately isn't a direct measure. So with this mechanistic evidence out of the way, let's now explore the direct evidence of the effects of protein on hypertrophy. The closest topic related to the question of this video, which we have direct evidence for, is the effects of protein frequency on muscle growth. If there was a limit to how much protein we could use for muscle growth in a single meal, then we would expect to see greater muscle growth consuming more frequent meals with lower protein amounts compared with fewer meals with higher protein amounts, even if total daily protein intake is equated. However, the evidence we have doesn't seem to find this. For example, this study explored the effects of different protein frequencies on body composition during resistance training. 24 elite developmental rugby players supplemented their regular diet with 3 protein shakes per day. Half the subjects were instructed to consume their supplements with their regular meals, while the other half were instructed to consume their supplements between their regular meals, with the aim to manipulate protein frequency. This was conducted for 6 weeks, while the athletes performed resistance training during the diet. Subjects consumed around 2.6 to 2.7 grams of protein per kilogram of body weight per day in both groups. The group consuming protein with their meals ended up consuming this across 4 protein feedings per day, while the higher frequency group consumed 6 protein servings per day. After 6 weeks, both groups experienced similar gains in lean mass with no significant differences between them. This study suggests that if total daily protein intake is high, the exact frequency of intake doesn't seem to be all that important for muscle growth. This would suggest that even if you consume higher amounts of protein in a meal, it isn't wasted protein. It seems that this can still be used for muscle building purposes and doesn't seem to be any different to consuming protein more frequently in smaller doses. Although it would be good to see future research comparing the effects of a lower protein frequency around 2 or 3 times per day compared with a higher frequency of around 6 to 7 times per day. Next, we can look at the evidence on protein distribution. This refers to how total daily protein is distributed between meals each day. So even if total daily protein is equated and we are consuming a set number of meals per day, should we be trying to evenly distribute protein between meals? Or is it okay for some meals to be higher in protein than others? Well, this idea was explored in this study, which compared the effects of protein distribution on muscle growth. 33 untrained men performed a hypertrophy-style training program 3 times per week for 12 weeks. Subjects consumed 3 meals per day with a standardized breakfast provided each day. Half the subjects consumed an additional protein supplement at breakfast, while the other half consumed the same protein supplement at dinner. This resulted in the group consuming protein at breakfast having a more even distribution of protein throughout the day compared with the group consuming protein with dinner. As we can see, the group consuming protein at breakfast consumed between 22 to 32 grams of protein at breakfast, lunch, and dinner, while the protein at dinner group consumed around 8 grams of protein at breakfast, but made up for it at dinner with around 55 grams. After 12 weeks, it was found that total lean tissue mass gains were a little greater in the group consuming protein at breakfast, shown in the blue, compared with consuming protein at dinner, shown in the orange, and this difference was considered statistically significant. This study suggests that we probably want to try and somewhat evenly distribute our protein intake throughout the day, and you may not be able to make up for a lack of protein earlier in the day by increasing your intake later in the day. This may somewhat support the theory that there is a maximal amount of protein that can be used for muscle growth in a single meal. It is possible that the high amount of protein consumed at dinner was not fully utilized for muscle building purposes. Although one caveat here is that total daily protein was not all that high in this study compared to what is usually recommended to maximize muscle growth. So maybe if total daily protein intake was higher, different results would have been seen. Another area we can look at to help with the question of this video is the body of evidence on time-restricted feeding. Time-restricted feeding is the concept of consuming your total daily calories within a specific window of time, usually a narrower window than usual. We typically find that time-restricted feeding doesn't have a meaningful impact on body composition compared with a normal feeding pattern if calories and macronutrients are equated. For example, this study compared the effects of time-restricted feeding versus a normal eating pattern on body composition changes. 40 young females with at least 1 year of resistance training experience performed the same resistance training program 4 times per week. Subjects consumed the same total daily calories and macros with a protein intake of 1.6 grams per kilogram of body weight per day. One group consumed their first meal upon waking, and the rest of the meals spread across an approximate 13-hour window, whereas the time-restricted feeding group consumed their diet between 12 PM and 8 PM, an 8-hour window. After 8 weeks, both groups saw similar changes in body composition with no significant differences in gains of fat-free mass. Furthermore, there were no significant differences in biceps and quad muscle thickness after the intervention. So contrary to the previous, this study suggests that if total daily calorie and macronutrient intake is equated, there doesn't seem to be any notable differences in muscle growth when implementing time-restricted feeding compared with an unrestricted feeding pattern. This suggests that we probably don't need to constantly stimulate muscle protein synthesis via protein intake throughout the course of the day. Not consuming a protein serving for a few hours throughout the day probably isn't going to have any major negative effects on muscle growth if you were still getting enough total daily protein. And the last body of evidence that can help us to answer this question is the research on plant-based versus omnivorous diets. As we previously mentioned, it seems that the essential amino acids, in particular leucine, seem to be important when it comes to triggering muscle protein synthesis. However, this acute elevation doesn't seem to be directly indicative of actual muscle growth when looking at the diet as a whole. This is because even lower quality protein sources are usually consumed in combination with many other foods in a meal and throughout the entire day. So despite some protein sources being potentially less favorable when it comes to their amino acid profile, the combination of multiple foods can often complement each other and result in a more complete protein serving. For example, plant-based foods are usually going to have lower amounts of most essential amino acids compared with animal-based foods. However, plant-based diets as a whole tend to promote similar muscle growth when compared with omnivorous diets if total daily protein intake is equated. This was seen in this study, which compared the effects of a protein-matched vegan versus omnivorous diet on muscle growth. 22 young men performed a 5-time-per-week resistance training program for 10 weeks. Half the subjects who were habitual vegans consumed an entirely plant-based diet, with the others consuming an omnivorous diet. Both diets consisted of eating around 2,800 calories per day and around 2.2 grams per kilogram per day of protein. After 10 weeks, both groups saw similar gains in quad, hamstrings, and adductor muscle volume, with no significant differences between them. So this study somewhat goes against the idea that our protein sources require a specific amino acid profile to maximize muscle growth. In the context of an entire diet, even foods that are considered low-quality proteins still seem to be effective at promoting muscle growth. In relation to the topic of this video, this suggests that the whole idea of trying to spike muscle protein synthesis with specific amino acids consistently throughout the day may not be something we need to focus too much attention on. Rather, it seems as though our total daily protein intake is more important for long-term muscle growth. So, based on most of the evidence, it seems that our total daily protein intake is probably more important than our per meal protein serving, or how many protein servings are consumed per day. So, how much total daily protein should we be consuming? In general, we find that higher protein intakes tend to be superior for muscle growth, but see diminishing returns with higher intakes. This was established in this meta-analysis, which compiled the body of evidence on the effects of total daily protein intake on muscle growth. This graph shows the relationship between protein intake, measured in grams per kilogram of body weight per day, and changes in lean body mass via resistance training. As we can see, more protein tends to result in greater gains, but there appears to be diminishing returns with higher and higher intakes. Consuming around 1.5 grams per kilogram per day will probably get you the majority of potential gains, while 2 to 3 grams per kilogram per day might be necessary to get absolutely maximal gains. So as a general recommendation, I think that most lifters should probably aim to consume a minimum of around 1.5 kilograms per day and further increase this if it is feasible for you. Furthermore, this minimum recommendation can further be individualized based on body fat, biological sex, quality of protein in the diet, and personal preferences. For a more detailed guide on how to individualize protein intake, check out the video linked in the description. So, is there really a maximum amount of protein that can be used in a single meal for muscle growth? Well, this theory is mostly supported by anecdotal and mechanistic evidence. It does seem that consuming more than around 20 to 30 grams of protein in a single sitting doesn't seem to promote much of an additional spike in MPS acutely. Although this isn't very strong evidence because MPS isn't directly indicative of long-term muscle growth, and only tells us what is happening over a short-term time frame. In reality, muscle growth is a multi-day process, not something that happens within a few hours post-exercise. Although some evidence does find that a more even protein distribution pattern tends to be more favorable compared with consuming a different amount of protein at different meals. This would also support the theory that consuming too much protein in a single sitting may not be fully utilized for muscle building purposes, and cannot make up for lower protein intakes in other meals. However, I would say that there is stronger direct evidence supporting the idea that if you were consuming a high protein diet, the exact frequency and distribution of protein intake isn't all that important. The evidence tends to find that the number of protein feedings per day, or even intermittent fasting, doesn't seem to influence muscle growth to any meaningful extent. So our first priority should be to consume enough total daily protein per day. This should be around 1.5 grams per kilogram per day as a minimum for most people, if your goal is to maximize muscle growth. Once you are able to achieve this, then we can think about the specific timing and distribution of protein. Although it is not conclusive, it might be additionally beneficial to consume at least 3 meals per day, evenly distributed in terms of timing throughout the day, and evenly distribute protein between these meals. Thanks for watching, and hopefully you got something out of this video. Check out flowhighperformance.com for online coaching, training templates, ebooks, and more.